Hello, everybody. Welcome back. Robbie and Lizzie with you here today. This is take two. The first video I made last night, but I wasn't feeling too well. I didn't like it. I deleted and I restarted today. Okay, today's class. This is going to be interesting. I hope I'm going to make it quick. I'm going to cover 27 part of the refrigeration system. Okay, so this is my final test from October 1994. After high school, actually, during high school, I went to a trade school, but they don't teach you much. They teach you enough to pass a test. As you know by now, the red is high pressure vapor, the orange is liquid, high pressure, blue is low pressure liquid vapor mix, and the light blue is 100% vapor, low pressure liquid vapor mix. Alrighty. And number 1 and number 19, the metering device are in black because they're not high or low, they're in the middle. The red number 5 ends with number 18. Orange to red is high pressure vapor, orange is high pressure liquid. And then the low side is dark blue and light blue, liquid vapor mix, and light blue is vapor mix. All right, let's get going. I think Lizzie doesn't wants to go away, Lizzie. Let her go away. All right, next slide. It's not working. Next slide. Okay. So as I said, they just teach you how to pass a test. I really didn't learn much in this class. They just teach you how to pass it. I passed the test. So this is the answers, and this is the test, and the paper I had to draw on. So let's start with the metering device. As we know by now, the metering device regulates the flow. Okay, so the metering device is a device controls the flow of refrigerant from liquid line to the evaporator, right? Metering device controls the superheat and makes sure no slugging at the compressor. I'll cover slugging more later when we do compressor, when we do expansion valve, and when we do evaporator. A metering device or expansion device restricts the flow of high pressure liquid refrigerant, causing a sudden pressure drop. This drop forces the liquid to rapidly expand and cool, turning into a cold, low pressure vapor liquid mix before entering the evaporator coil absorbed by indoor heat. This is a Google search, and Google search is wrong. It goes out liquid vapor mix. I did that on purpose so you can, when you do research, not everything's correct on the internet. And I put the spray bottle to remember liquid vapor mix when you spray the bottle. Number 1, we have the automatic expansion valve. It's adjustable. It is very rare. The most common is the TXV. It's also adjustable thermostatic expansion valve. We have internal or external equalizer valve. We have sweat or flare connection. And we have balance port or standard. Also, number 2 over there picture is thermostatic expansion valve, have external equalizer and flare connection. You can see the picture is a little different. Number 3 is the electronic expansion valve, similar to the thermostatic, but it works on electronic. And the 4 and 5 is the fixed orifice and the capillary tube that are non-adjustable. I will make a video on all 5 metering devices and cover the thermostatic expansion valve in great detail. This video is just about all the major components, all the parts of the refrigeration system. We also have 2 more not in use anymore, but it's not bad to cover them a little bit. Slugging is very important word in HVAC. It refers to a dangerous and destructive phenomenon where unevaporated liquid refrigerant or mix of liquid oil enters the compressor and slug it, because you cannot compress liquid. Liquid is the strongest thing that is, believe it or not. The Grand Canyon was made by liquid. So what do you think liquid's going to do to the piston of the compressor? I'll cover more slugging in details when I do compressor. But now let's move on. Next slide. Lizzie's sleeping on my leg, Lizzie. Lizzie fell asleep on my leg. All right. Next is the distributor after the TXV. Oops, wrong way. All righty. The distributor. Distributors are not needed for small evaporators. Distributors only for large evaporators. A small little evaporator doesn't need it because we don't have pressure drop between the beginning and the end of the evaporator. I know in first video I said there's no pressure is the same on the low side. It's not. We say it is, but on large evaporator, pressure changes a little bit. So the function is it evenly split the flow of liquid refrigerant into multiple smaller tubes that feeds into different circuit of an evaporator. This is an A-frame evaporator coil is a good example of an air conditioning standard AC at home. As you can see, it splits 4 different sections. So we actually have 4 evaporators in one. It splits it so we'll have even temperature everywhere for better efficiency. So number 1, subcooled liquid from the condenser enters. Number 2, expansion in the metering device distributor out 80% liquid vapor mix, 80-20. And number 3, freon in the evaporator will evaporate and become superheated vapor out from the suction line to the compressor, out from the evaporator to the suction line to the compressor. Alrighty, next slide. Next slide. Evaporator. Next is evaporator. We have many kind of evaporators. Some are water cooled, some are air cooled. Starting from top left to right, this is a regular refrigeration evaporator, but it's upside down. That first picture. Second picture is a walk-in box evaporator. That's a walk-in cooler. And the other 2 are also refrigeration evaporators. Down at the bottom, the arrow, that's a water-cooled evaporator that looks like a water chiller. And that's a shell and tube style, I believe. We have shell and tube, tube and tube, tube and tube, tube and shell. We'll cover that when I do the evaporator part. We also have ice machine evaporators and static evaporators. And we also have, and we have the new microchannel evaporator. It's more efficient. It looks like a car radiator, more efficient. I'll cover it in details when I do evaporator section. Now we have to move on to the next slide. Suction accumulator is next. Okay, suction accumulator. Suction accumulator pretty much main job is to make sure no liquid refrigerant go to the compressor because we don't want slugging. You're not gonna see it in air conditioning, it's not needed. And you're not gonna see it in refrigeration. It's only for freezers, for low temp and ultra low temp. Now, another small lesson here. We have high temp air conditioning, temperature 75, boiling point 35, medium temp refrigeration, temperature 35, boiling point 20, freezers 0 degrees, boiling point or evaporation temperature at -10. And we have ultra cold, ultra low temperature, below 20 for medical industry. A student graduated and now he's working on ultra cold, the machine that keeps the embryo frozen. And that's something above my scale. I never worked in ultra cold. And this suction accumulator have 4 pipes in it. I'm trying to figure out why 4 pipes and some kind of pressure regulator and some kind of oil regulator. I'm not going to say it's oil because it's above the oil level, oil at the bottom, but some kind of valve between the high side and the low side. If I have to guess, I would say this probably have to do something with temperature because suction line is so cold. Box temperature below 20. That means boiling point is at -40, maybe -30. That means liquid line is so cold. We can't have liquid lines. Suction line is so cold, causing the liquid line to be cold. In freezers, the liquid line is cold, even though the pressure is high, because all the coldness from the low side causing the high side to be. What I'm thinking this is to keep the liquid line warm, so we'll have some kind of subcooling. I don't know much about ultra cold, ultra low temperature. I never worked on it. That's another level, but I mentioned it here to get you excited into refrigeration because there's so much to learn in this trade, and it's so fun and it's so cool to always learn stuff. You don't want to be stuck doing the same thing 20 years of your life, same thing every day, same thing every day. Somebody shoot me with a gun right now. This HVAC is so cool because always learning new things, improving ourselves to become better people, better technicians by learning. All right, so let's move on now. So this is ultra cold for some reason. So suction accumulator job to make sure we don't have slugging to the compressor. Next, Okay, so we have evaporator pressure regulator valve and EPR and CPR valves. We do them together. Alrighty. So the evaporator pressure regulator valve, EPR. First, let's go the EPR valve on the right side, then I move to the CPR. The EPR job, the EPR valve is to maintain a constant minimum pressure and temperature inside the evaporator, preventing it from dropping below a certain predetermined limit in multi-evaporator system. What this means is that by controlling the pressure, I control temperature. Okay. For example, air conditioning should be 75-degree air in the building. That means coil temperature should be 35. I don't want this coil to be below 35. If it goes below 35, people will be super cold. Thermostat, I can set the thermostat at 0 degree on the air conditioner. We'll never get to zero because the CPR, the evaporator pressure regulator, will keep pressure above certain temperature. This is important in refrigeration when you have supermarket with multi-evaporator system, one for produce at 50 degrees, one for eggs at 45, one for beer and soda at 35, one for meat at 25, and one for regular food at 38. Different products need different temperature, but they all share one compressor. So that's why we have EPR valves. As you see here, we have 5 evaporators, but 4 EPRs. Okay, why 4 evaporator pressure regulators? Because the coldest one is not needed. The one running at 15 psig, which this is our, we don't know what Freon this is. It looks like our R134A. So whichever, the coldest, this is whichever, add 20 degrees, you get the temperature. So therefore, the coldest one doesn't need EPR. All right, but the other two do, as you can see. The 18 psi does, the 25 have one, 20 and 30 have one, but the 15 doesn't. So whatever happens, the other 4 evaporators will never go below certain temperature. That's the crankcase EPR, evaporator pressure regulator. Now, CPR and EPR, they look the same, very similar. They're both located on the suction line, but one close to the compressor and one close to the evaporator. Relax, it's less confusing on the field because of the location of the CPR and the EPR. Okay, and CPR with multi-evaporator system, EPR is for freezers. I'm sorry, the other way around. EPR for multi-evaporator, CPR is for freezer, is a specialized pressure reducing valve installed on the compressor's suction inlet, automatically throttle suction gas to prevent vapor from rising above a value set point, protecting the compressor from overloading during heavy load condition. So we have a walk-in freezer or any freezer. Temperature usually is 0 degrees in the freezer. Evaporation temperature is -10, but defrost temperature is 40 now. After defrost, temperature is 40. The pressure goes up like crazy for the compressor. There goes your amperage, rated RLA, the rated load amp. Crazy. The boom, compressor will break, will overload. So we need the CPR. Okay, another example. We need the CPR to prevent the compressor from overloading. So EPR prevents pressure from dropping below a set value in the evaporator. That's EPR. Another example here. See here we have EPR for the 25 psi. The 18 doesn't need one. So EPR job to keep pressure high. Now the CPR, crankcase pressure regulator, keeps pressure low at the compressor after defrost on a freezer. And there's a location of it. One is before the compressor and one is after the evaporator. All right, let's move on next. Next, we have the suction line solenoid and liquid line solenoid. We put them together because solenoid valves go together. Solenoid valves is a very big part of refrigeration and air conditioning. Air conditioning, not as much. Now, the modern air conditioners, yes. Because with the Freon 410, the pressure is so high on the high side, not enough to hold in the liquid receiver on shut off. So they need that solenoid valve to shut off the liquid line. So solar valve, it's a electromechanical device used to control the flow of liquid and gases. It's also used in HVAC to control flow of fluid, vapor refrigerant, liquid refrigerant, and water. It opens and closes when EMF, electromagnetic field. I covered that when I did Ohm's law. Is formed around the coil when a certain voltage applied. It's either 24 volt, 120 volt, or 240 volt. We have the coil, which is you can replace it whichever voltage you want. And we have the body, and we have coil and body. And we also have the hot gas valve. The teacher, when I was in school, didn't mention it back then. And it's used very on ice machines, ice machine, hot gas harvest. Harvest is for the ice to drop. And also we have water inlet valves used on ice machines. And on top, also we have a magnet tool. We also have some valves with a manual stem at the bottom, so you can open and manually open it. They leak Freon. I never installed it. They should not be, I don't like them. They never should not be even exist. Pretty stupid. If there is no power and you have to recover or do something, if there's the only thing you're going to do if there's no power is pretty much to recover, remove the refrigerant. And you can't do it if this valve is closed. So you use a magnet, a little magnet, you put it in, boom, will open the valve. All right. The magnet to open the valve is a lot easier than to unscrew the screw, pain in the butt, and they leak Freon. Anyway, note, a modern ice machine have at least 3 solenoid valves: inlet water, outlet water, and hot gas valve for defrost, for harvest. Some machines with a remote condenser could have up to 5 solenoid valves: liquid line valve, hot gas valve, water inlet, water outlet, and another liquid line valve if it's dual evaporator. Ice machines, another subject for another time. That's my baby. That's my specialty. First, you learn the basic refrigeration, then move on to the ice machines. Then we move on to the air conditioning, variable frequency flow, and VRF, all the fun stuff. And now the new hybrid VRF, totally fascinating stuff. All right, next, I put the compressors, unloaders, external unloaders, and crankcase heaters all one together and for this video. And the compressor, we know what it is, the heart of the system, device that takes in vapor refrigerant and discharge also superheated gas to the condenser, right? It's the heart of the system. It's a pump. It's a vapor pump, remember. And we have 5 kind of compressors. All right, anyway, the electronic unloader and automatic unloader, they go on the compressor. That's a semi-hermetic reciprocating compressor. That one looks like it have 3 heads. And then what's happened is I worked on this before, back when I had my business. And then how it works is that compressor is one stage, alrighty. But then when the unloader is on, compressor is full capacity. When unloader is off, the piston will just go up and down doing nothing. It's not gonna pump. So it'll be a third capacity in this case, 2 running and 1 not running. So that's what an unloader does. It's for big compressors. All right. Then we have the crankcase heater. It's a little heater that goes around the compressor in the off cycle to keep the oil it's called fractionation, for the oil not to. It's part of the chemistry. I'll cover it when I do the Freon and oil class. And fractionation is also very important in HVAC. It's not a problem here in Florida, because temperature never gets below 50 degrees. So I don't think you even need crankcase heaters here. We don't even need HPR valves here. I mean, Headmaster, cover later. Anyway, compressors. We have the rotary is the smallest. We have the receptacle. Excuse me, the reciprocating. I misspelled that. Reciprocating compressor, misspelled it. The reciprocating have pistons up and down, and we have the hermetic and semi-hermetic. Hermetic is a Latin word for secret or hidden. For secret, hidden is latent, and then because inside is hidden. So then, rotary is smallest, reciprocating is next. The big second scroll, and there's many ways of scroll modulations. The two biggest ones is screw, and the biggest one is centrifugal. The screw and centrifugal, I never worked on. That's one step above. I never worked in industrial or huge buildings, but I've seen the screws in action. And my friend works at Oracle, big computer company back home in Bay Area, and we were going to San Francisco for a heavy metal concert, and he told me, "Come by, stop by, I'll show you around." And amazing, big stuff. It's very cool. Seeing it's a completely different way to cool and heat a commercial building than do a house. That's when you need the screw compressors. Woo! Very loud. We have to put, you walk into the mechanical room, you got to put the ear thing on your ears. Anyway, and it's so cool. Technology advanced so much. Now they have oilless system, no oil at all in the system, and all electronic technology advanced so much in this business. It's so cool. But I will do a class just about the compressors. I can talk an hour about the compressors, but for now, let's move on. We also have oil separators. The big compressors need oil separators because oil is, without oil, compressor will burn. We need oil. So this is the oil separator. It goes between the compressor and the condenser. I just mentioned it here because it's part of the refrigeration cycle. Next, we have the high pressure relief valve. Oh, I did not put that in, huh? Ooh, look. My apologies. I did not put the high pressure relief valve. I only put the high switches. The high pressure relief valve, you don't have to worry about it. It doesn't exist anymore. It's something old. Now by EPA standards, you cannot vent Freon no more. So it doesn't exist anymore. So the pressure controls are everywhere in HVAC. They have many functions. Some we can adjust the cut in, cut out, or cut out and differential. I mean, cut in and differential. A whole class about pressure control adjustments. There are high and low pressure safety. They use as high and low pressure safety. They use for pump down or pump out. And they use as condenser fan on and off to control subcooling. And they're used in some ice machines for harvest and the isomatic ice machines. They have many functions. Low pressure control is also used as a temperature control. It's very rare, but you have to know how to adjust it properly by adjusting the cut in and the cut out on the dew and the bubble of the low side pressure. I'll explain the dew and the bubble when I talk about the Freon and the chemistry going on between vapor and liquid, how some Freon will evaporate at different rate as other Freon, depends if they are mixed or not. And to find out the dew and the bubble, to find out the bubble of the low side, because bubble is on the high side, you actually have to look at a different PT chart than the one we have PT chart. I'll explain all this when I do the refrigerant class, how to adjust the pressure control and step control in refrigeration. But it's rare to do that, very rare. I only did it 4 or 5 times in my life. But let's move on now to the condenser, to the heat rejector, huh? Heat rejector, we know what the condensers are by now. But there's a lot more going on. I will do a class just for the condensers. Condenser, the heat rejector. It's a long tube that rejects the heat. Okay, and in the condenser, first we have Freon comes in superheated from the compressor, superheated from the compression. Then it desuperheat in the liquid line, in the discharge line, desuperheat in the beginning of the condenser, then it condenses, then subcooled. And we have many kind of condensers, AC condenser. This is a remote condenser. It could be for air conditioning or refrigeration or freezers. No way to tell from this picture. And we have the new microchannel condensers. We have static condensers you see behind the small refrigeration in the back. Static means no forced air. And we have water-cooled condensers, shell and tube, tube and tube. I'll cover condensers in another section, another class. Next, the liquid line and liquid receiver. The liquid receiver's job is to store refrigerant. Liquid receiver job and TXV go hand in hand. Liquid receiver is not needed on water-cooled equipment. Why? Because water doesn't change. Water temperature doesn't change much, maybe 2 or 3 degrees. Water temperature is always steady. Here in Florida, water is warm. But back home in California, water is always 55. Unless you're in Gilroy, water is 70. But so therefore, we don't need the liquid receiver. Why? Because during summer, we have less heat. We have more heat in the air. It takes more to to reject the heat from the condenser. Alrighty. So therefore, the liquid receiver is empty in the summer, is empty, and all the freon is in the condenser. Right. But in winter, it's the other way around. We have less heat in the air. We don't need to reject that much heat. The liquid receiver is full of freon, and the condenser doesn't have that much freon in it. So liquid receiver's job is for winter and summer to, depends on the temperature outside. If temperature is very, very hot, the liquid receiver is going to be empty, freon in the condenser. If the temperature is very cold outside, then freon will go in the receiver. Okay, it's not needed on cap tube systems. It will make damage if it's a cap tube system. Liquid receiver is a very important part of refrigeration and air conditioning. Small systems don't have it. It's not needed. Big system is needed for sure. Also, if you have leak, you don't have to recover all the refrigerant. You can store, it's also a storage device. You can pump other, it's called pump down, pump all the refrigerant into the receiver and save it there, do whatever you want to do in the system, and then open many steps before we open. Okay, anyway, this picture is a good one here. It shows suction line in the blue, light blue suction in from the evaporator. It goes to the compressor on top. The whole body of the compressor is vapor and a little bit discharged inside. And then liquid discharged red goes down and up. It goes down and up like this because vibration. So it doesn't break. It's like a vibration eliminator kind of. Goes to the condenser vapor on top. Condenses first, de-superheat, condense, goes liquid. That's why it's called liquid receiver. Receives the liquid, goes out behind the compressor liquid out to the metering device, to the evaporator, back circles and circles we go. All right, next. Condenser pressure regulator valve. Wait, CPR, we did that already. Oh no, oh yeah, he called it condenser pressure regulator valve. Condenser pressure regulator valve, but it's technically called high pressure regulator valve. High pressure regulator valve. I guess you can call it condenser pressure regulator valve, but that's not the right term. HPR or headmaster is also known as headmaster, the slang. So this will be our job will be easy if in a perfect world, temperature outside will be always the same, 75 degrees or 10 degrees, whatever. In a perfect world, temperature doesn't change. But we don't live in a perfect world. So that's why we're here. So if outside temperature is 40 degrees, right, what's going to happen to that? Now look at the small box. Look at my hand. We have high pressure here, low pressure here, okay? On a very cold day, right, what's going to happen to the high pressure here? It's going to drop, causing the low pressure to drop. Okay, because high pressure drop, low pressure drop, nothing will work. Now, we cannot remove heat no more if the low pressure is so damn low. Compressor is going to cycle on, off, on low pressure. So we have to maintain the high pressure properly. And how we do that, there's many ways to maintain subcooling or maintain the head pressure. One of the ways is the HPR valve. It will bypass some of the freon, some of the vapor hot gas to the receiver to keep pressure high. So remote unit with HPR valve, some discharge gas is bypassed to the receiver, right? Why? Because ambient temperature 40 degrees. The other slide, you see remote ambient temperature above 60 degrees, no bypass. The one on the left side, the one on the right side, the outdoor temperature 80 degree is just normal refrigeration system, right? Discharge to the condenser, out to the receiver. You can see by color, red, pink, and then low side. Over there, you see red, but some of the red going down to the receiver, See that? To keep the pressure high. Because if the high pressure goes too low, the low pressure goes too low, nothing works. So we'll cover again the headmaster, the head pressure regulator valve, or the headmaster in great detail when we talk about condensers. And when we talk about subcooling control, there's more than one way to control subcooling. And how to know when it's full, when enough to charge. I had a couple of problems before. I thought I had a leak because low in freon, but it's not low in freon. It wasn't charged properly. It's a very big mistake people do with the HPR valve. But I'll cover it again in details later when I do condensers. Now we have to move on. Next slide. Okay, the filter dryer, side glass, and moisture indicator. All right, so we have the filter dryer job is a device to trap dirt and moisture in the system. The filter traps all the dirt in the system, and the dryer picks up the air because moisture is our enemy, our second enemy. First enemy is heat, second enemy is moisture. All right, we have the liquid, the side glass is to look at the Freon inside and to see if it's bubble or not. And we have the side glasses inside the moisture indicator is inside the side glass. Moisture indicator inside the side glass. That's to tell us if there's moisture in the system or not. Right. But don't get confused with the muffler. It looks like the filter dryer, right? But it's not. It's a muffler. It says on it muffler, and it's on the discharge line. It's not on the liquid line, and it's just for noise. Okay. And we also have suction line filter. I included with the filters. Suction line filter is just a filter. It's not a dryer, only a filter. And suction line filter also have many reasons to use it. We try not to use it because we don't want restrictions on the suction line. It's mainly used if we have acid in the system, so it can pick up the acid to clean up, for cleanup. And it have place to check for pressure, suction line filter, because that's how we check if the filter is clogged, is the pressure before the filter. Some only have one. You don't need two. You only need one because the other one you can get at the pressure of the compressor. Right? So that's how we know if suction line filter is clogged. The liquid line filter, we know it's clogged by temperature, which is also rare, but it happened to me a couple of times. I've been doing this so long. I'll cover filter dryers again in detail whenever another class. And we also have the heat exchanger. The heat exchanger nowadays, when we talk about heat exchanger, it's a metal plate like this and freon in and fluid out. This is the new heat exchanger style. It's a condenser or evaporator. It's cooling or chilling water fluid, or in some cases, O2 in the new hybrid variable frequency drive air conditioning system, and actually using CO2, excuse me, CO2 also. This is the old style, the old style heat exchanger. It's pretty much suction line and liquid line go around it. I haven't seen that in 20 years. I don't think it's needed anymore. The whole purpose was it to make sure the liquid line doesn't, suction line don't sweat too much. But I guess now we have better installations now. I don't see it much anymore for some reason. It's not needed anymore. The old heat exchanger, pipe in a pipe. But at the bottom, we also have the cap tube, small cap tube is brazed around the suction line for heat exchange also. That's the heat exchanger. When we talk about heat exchanger, that's the heat exchanger. Pretty much anything that exchanges heat through conduction, because transfer through conduction is the best heat transfer. Remember from first class, conduction, radiation, and convection, right? The best is the heat transfer is conduction. Lizzie, what's Lizzie doing? Lizzie went down there. She's playing. Alrighty, last but not least, thank you. One more slide for fun. And we have the vibration eliminator. Eliminator is the last thing. Semi-harmonic compressor comes on, shakes. So we have one here installed in the system on the discharge line. As you can see, going discharge line to oil separator. Huh, interesting. Oh, no, wait, that's suction line. Whatever that is, that's suction line. No, whatever that is. That's a vapor. No, it's a discharge line, oil separator to the condenser, correct. And then we have, it goes there. Whenever whoever's going to install this unit, you need to install a vibration eliminator. All right, one more slide for fun. What's wrong with this picture? Give you a moment here while I pick up Lizzie. Lizzie, what's wrong with the picture, Lizzie? All righty, there we go. Lizzie, what's wrong? Next slide. There we go. Suction on top, people, always. All righty. Discharge, correct, on top. Vapor on the top, correct. Vapor turns to liquid, correct. Liquid at the bottom, correct. Goes to filter dryer, correct. Capillary tube metering device, correct. And on top, correct. But then it should be on top. Vapor goes back on top because the other way, the guy had it the other way. Well, that was the compressor slugging. Liquid at the bottom caused compressor to slug. It is amazing how many wrong things I see online, people. Thank you. Thank you for me. Thank you for Lizzie. Any questions, please, you know how to contact me. I'm easy to find. Leave comments, share video. Let me know how I did. Thank you and have a wonderful day, and God bless and all the good stuff. See you next time whenever I see you. Peace, love, and happiness.